All right, we're back for a double recording into 10-3. This is chords. A chord is a segment whose endpoints are on the circle. So in this circle, MN is a chord, PQ is a chord. What's the longest chord in any circle called? A diameter. Good shout out from Lilo over there. So what are we learning here? Again, most of these things make sense. If the chords are equal, then the angles that intersect those chords are equal. That makes sense. And then the converse is also true. So if the angles are equal, then the chords are equal. Okay? And I think I've already taught you this, but if I haven't, let me tell you again, or if I have, let me tell you again. If that was a circle, because I ran out of room, if the angle of the circle was x degrees, how many degrees would the arc be? X degrees. They're the same. This it's so hot in here, it's picking up the heat from my elbows. I think that's why it's making these weird lines. So that's your first theorem. Pause the video. If I was in your shoes, I don't think I would write these down because they make sense to me. But if they don't make sense to you, you should write them down. But if you're confident that you could look at that, be like, yeah, I get that. That's true. Then you don't have to write it down. Look at this one. If the chords are equal, then the arcs are equal. That's a little bit different than what we just said. If the chords are equal, then the arcs are equal. And then the converse says, if the arcs are equal, then the chords are equal. I'm good with this one. I don't need to write that down. This one just says, if the chords are equal, then they're the same distance from the center. If you think about that, the closer the chord is to the center, the bigger it gets. So if they're the exact same length, then they must be the exact same distance from the center. And this one just says the converse. So if they're the same distance from the center, then they're the same length. So this is actually going to be a lot of theorems, but a quick video, and then we're going to get a hard one. And I bet it's coming up next. Another theorem. Holy smokes, more theorems. If the chord is bisected perpendicularly, then that thing that's bisecting it must be a diameter. That might not be as intuitive. So if we cut a chord in half at a perpendicular, that has to be a diameter. And the converse is also true. If something is a diameter, then it's the perpendicular bisector of the chord. You might want to pause and write that one down. Here's our example. Nope, more, this is crazy. More theorems. The perpendicular bisector of the chord contains the center. Well, if it's a diameter, it's got to contain the center, so I don't need that one. Now we got a great little engineering problem here. So we're building a tunnel. The tunnel has been built. How high is it safe for trucks to go inside of it? Okay. And then at the end, they want us to subtract a half a foot just in case we were wrong or the pavement guys were wrong, because we don't want any truckers suing us, or even worse, people that were behind the truckers suing us, because that's who'd be suing us. Okay? What's the diameter of this circle? 27. So that's going to be important. What's the radius? Of course, they had to give us an odd number. So what's half of 27?
13.
All right, so the diameter is 27. Thank you, Hallie. The radius is 13.5. We're dealing with feet. This is 6. It's essentially we have a rectangular window that our trucks can pass through, okay? Because the trucks are rectangles. And this is 18, which makes this 9 and 9. There's that bisector theorem into play, okay? I'm going to put the center of my circle on here because I know that's going to be important. And they want to know what's the height, the biggest height we can accommodate. So that's what they want to know. Okay? Now, if we had a little more time, I'd let you guys play around with this and see if you can figure it out, but we're kind of short on time. So I'm going to call this y, knowing that y is half of x in this picture. Is everybody okay with that? And then this is the key. You got to draw your radiuses. Because what did we say our radius was, Hallie? 13.5. And up here, this is 9. So, Caden, how are we going to find y? You've been on fire today with your Pythag. 9 squared plus y squared equals 13.5 squared. So y, can anybody do this for me really quick? Square root of 13.5 squared minus 9 squared. 10.06 feet. So then our total height is twice that. So that's 20.12 feet. Okay? But we don't want to get sued, so we're going to listen to our lawyers. And we're going to adjust our max height by how many feet? 0.5. So this is going to be 19.62 maybe? That's the maximum height we can take. Has anyone ever been on that site called 11foot4.com? I think it's called 11foot. Look for it, but I think it's 11foot4.com. Big shout out to Daniel Chen, who was an original OG SynLabber, first class. I had him in Geometry Accelerated before the SynLab. And he would be on this website 24/7. Did anybody find 11foot4.com?
It's 11 foot 8.
11foot8.com, thank you. It's just a live camera of this. I think it's in Maryland, but it might be Pennsylvania. And it's blocked at school.
Oh, wait, no, it's not.
And it just shows all the trucks that have driven into this bridge that's too low. And there's thousands of trucks that have driven right into this bridge. So go ahead and check out 11foot8.com if you want. And shout out to Daniel Chen, who makes a celebrity guest appearance in this 5-minute lesson. Boom.